Texan Global School. Rules of Differentiation. In this class, we will discuss rules of differentiation and the chain rule. It is important to have the form of rules of differentiation that we have seen in previous classes at hand. We will also present the rules of differentiation for trigonometric functions. We can see that the derivative of the sine function is the cosine. The derivative of the cosine is minus the sine. The derivative of the tangent is secant squared. The derivative of the cotangent is minus the cosecant squared. The derivative of the secant is secant times tangent. And the derivative of the cosecant is minus cosecant times cotangent. The proof can be obtained using the definition of derivative. For example, we will show that the derivative of the sine function of x is the cosine of x. Let us define each function to substitute in the definition of derivative. We get the limit as h approaches 0 from the sine of x plus h minus the sine of x over h. Recalling a trigonometric identity, we know that the sine of the sum of two angles is identical to the sine of the first angle times the cosine of the second angle plus the sine of the second angle times the cosine of the first angle. By expanding and grouping algebraically, we have two terms. So, by applying the limit to each term, let us also apply the limit to the products. By sending the corresponding limits, we verify that the derivative of the sine of x is the cosine of x. Using then the definition of derivative, all the formulas of trigonometric functions can be verified. In case of having composite functions or some composition of functions, then, use the chain rule. If g is derivable at x and f is derivable at g from x, then the composite function is derivable at x, and f prime is given by the product where the derivative of the composite function is the inner function g inside the derivative of the outer function f prime, multiplied by the derivative of the inner function g prime. We can then see the chain rule adapted to the rules of differentiation demonstrated above. If we have a composite function in a power, for example, the derivative will be n times u to the n minus 1 times the derivative of u. In the case of trigonometric functions, we can essentially see that the product of the derivative of u is included. Let's look at an example. Let us differentiate the square root of 1 minus x cubed. Specifically, we do not have a differentiation rule for square root. However, using laws of radicals, we can transform it as a power. Then, we have 1 minus x cubed to the 1/2. In this way, we can differentiate as a power. We can see that the base is a composite function, so use the chain rule. According to the rule, the derivative will be n times u to the n minus 1 times the derivative of u. N equals 1/2, and u is 1 minus x cubed. So, results 1/2 times 1 minus x cubed to the 1/2 minus 1 times the derivative of 1 minus x cubed. Expanding algebraically, 1/2 minus 1 is minus 1/2. By using laws of exponents, let us represent with positive exponents, so lower that factor. The result is 1 over 2 times the square root of 1 minus x cubed, times the derivative of 1 minus x cubed. Now, differentiate the last missing section. Since it is a difference of functions, apply the derivative to each function. The first derivative is 0, since the derivative of a constant is 0. And to the next one, apply the simple power rule. Expanding once more, results 3 times x squared over 2 times the square root of 1 minus x cubed. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com